So today we're going to be doing lesson 8.1, and this is graphing parabolas and identifying properties. All right, so we're going to start off with the different forms that we could see quadratics or parabolas in. So we have three forms. Okay, so the first form is standard form. And it is y equals ax squared plus bx plus c. Our second form is vertex form. These are going to be the most common ones that you see. And that is y equals a x minus h quantity squared plus k. And our third form is factored form. And so that would be y equals a x minus p and x minus q. So we did factored form a lot last chapter because we were learning how to factor. Now we're going to learn more about using standard form and vertex form. So one thing I want to highlight is that this A is the one thing that is constant for all of them. And we will deal with that later on in this chapter. But for right now, for today, A is always going to be 1 for right now. Different forms give us different things. So standard form helps us identify two things right off the bat. So the direction that it opens, and if it stretches, so actually it's three things, so stretch or shrink. And again, that all comes from this A. So that's going to be the exact same thing that all of them tell us, but the one additional piece of information is that it identifies the y-intercept. Okay, and that comes from this letter C right here. This one helps us identify the vertex. Okay, and it's going to be a point where it's H, K. So it's always going to be the opposite of what's inside the parentheses. And this one helps us identify our zeros. Okay, this is also called our x-intercepts. And that's going to be what would make each one of these equal to 0. So it would be at P 0 and at Q 0. And again, this A tells us two things: the way it opens and how much it will stretch or shrink. And again, we won't come to that until later on in the chapter. So right now, we're just going to say they all open up. So let's go ahead and graph what we call the parent function. And that is y equals x squared. Okay, this is the parent function because it is the simplest form of all of the other forms. So this is in standard form. It's also in vertex form. It's just kind of hidden. But let's go ahead and make a table of values. And if I plug in -3, -2, -1, 0, 1, 2, and 3, if I say what's -3 squared, I need to include that negative inside, and so that gives us 9. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 2. Notice how I don't have parentheses around the positives. I can still add them. It's just not going to change that. And then 3 squared is still 9. So notice how we kind of have a pattern of the values of y. So my x's are both positive and negative, and they include 0, but my y values, they're only positive. So let's go ahead and quickly define our domain and our range. So our domain are the x's, and our range are the y values. Okay, let's graph this, and then we're going to use this to define a lot of other things. 1, 2, 3, 1, 2, 3, 1, 2, 4, 5, 6, 7, 8, 9. Okay, so this is 9. This is 1, this is 2, 3, 4. Okay. All right, so if I plot my points, I'm going to put this one in red, okay? And then I'm going to put the other ones in orange. So we have left 1, up 1, right 1, up 1. -2, 4, and 2, 4. -3, 9, and 3, 9. And we're going to have this shape. Now, if I did 4, what's 4 squared? You get 16. So, and that's supposed to be a curve right there. All right, so if we did 4, it would go way off the chart. So I'm just going to draw an arrow and know that the next point would be 416. So now we're going to identify 10 characteristics of this graph. So we have the vertex, the maximum or the minimum. You can only have one of those, and we'll encounter those later. When is it increasing versus when is it decreasing? What is the axis of symmetry? So that's a new word. What is our domain and our range? What are the x-intercepts? What are the y-intercepts? And then what direction does it open? Okay. All right, so let me just change this really quick. And let's say, okay, our vertex we did in red. So our vertex is this point right here. Vertex. And that is the point 0, 0. It's the point where it turns. Now, this graph will have a minimum value because we're looking at the y values. And the smallest minimum, or the smallest value it will have is 0. So you can say minimum value is 0. And then we want to look at the graph, and if we put our finger on this top point right here, on the top of the graph, and then we move it, then in order to go to, or sorry, move it to the right, because we go left to right. In order to do that, we have to start up here and go down. So this is my decreasing interval, and we're decreasing all the way until we get to our vertex. And that is going to be our x values. So that is when x is less than 0. It's not increasing or decreasing at 0, so it's not included. And then after 0, we are going up, so greater than 0. Now, our axis of symmetry is a line that splits it and makes it symmetrical, meaning it's the same on both sides. And that line crosses the x-axis, so it's going to be x equals, and then where does it cross the x-axis? Well, it crosses through the vertex, and it crosses when x is 0. Our domain is all reals, all the time. Our range, our y values are greater than or equal to that minimum value right here. X-intercept is 0, 0. Y-intercept is also 0, 0. We could have more than one for that, but we're not guaranteed. And this one opens up. Those are all the properties. Let me know if you have any questions.